Okay, ठीक है. Then अगर light, if the light is rotating towards, if the plane rotated towards right, so what's the name of that?
Dextrorotatory.
Dextrorotatory.
Dextrorotatory. And if it rotated towards left, then it is
Levorotatory.
Levorotatory. ठीक है. Okay. ठीक है. उसके बाद हम लोगों ने देखा what are the conditions. तो when is a organic compound optically active? So क्या होना चाहिए?
Symmetric. One second.
11th or 12th? 12th, first class. Okay, sir.
It should not superimpose, therefore it should not be symmetrical. If you want optical activity.
So the criteria is it should not, the mirror image should not superimpose with the original compound, right? For it to be optically active, okay? And how will you see a molecule and then say that, okay, it is optically active or not?
If it has two same substitute to the carbon, if two of them are the same atoms, molecules, then it's symmetrical and therefore it's not optically active.
Okay? So if to a particular carbon, all the 4 groups that are attached to it are different, then it is optically active. Okay? Optically active or chiral or asymmetrical. Okay? Okay, so then we talked about okay, so hi, what's tell me your name, tell me why do you like chemistry. Okay, there are 4 questions. Name, why do you like chemistry, then your school, and 4th point is your hobbies. Okay. Okay. See, you can be honest also. If you don't like it, that's okay. Reading books and which sport? Okay, which position? Midfielder where? CM, DM, attacking midfielder. Nice. Nowadays, the number 10s are decreasing. Do you know that? Earlier, it used to be Mesut Ozil. Then there used to be one more player. I forgot. Proper number 10. Nowadays, they're decreasing. Nowadays, you have more of CMs and DMs. Okay, no one else is interested. Okay, so do you know this chapter, by the way? You just crashed in the middle of the chapter. Haloalkanes and Haloaranes. No idea, right? Okay, but we have some lectures. So do one thing. Try to understand whatever is going on today. And then I will be sending you the lectures. Okay? Fine. Okay, so Elisha, tell me what is a racemic mixture or racemization? What is that? Don't ऊपर मेरे को देख. Yeah. Fine, honesty. So what is racemization? ऊपर देखो बे सब. ऊपर देखो.
I don't remember what I don't remember what that is, but I remember what enantiomers.
I know what racemization is.
Yo, let's go. Yes, tell me.
Okay, racemization is when there are basically it's 50-50. So 50% of the getting to, I think it's I forgot how to pronounce that word.
Enantiomers.
Enantiomers in 50-50 ratio.
Good. Okay, Priyal, want to try?
Yes, sir.
Want to try?
Yeah.
Bolna.
It's the process of conversion of any enantiomers.
Yeah.
Any enantiomers.
Enantiomers. English has left the chat, guys.
Into a racemic mixture.
Okay, so I told you that a particular, okay, just you guys need some revision. Okay, so I told you that a particular optically active compound, okay, so it can exist in two forms if it is optically active. Remember, one can rotate the right towards right, and the other one come and sit. Okay, so one can rotate the right towards right, and the other one can rotate the right towards left. Okay, so a optically active compound can exist in two forms. So this is known as the D form, this is known as the L form. Okay, see here everyone, I'm using the small d as a symbol. That D stands for, what does that D stands for? It is rotating the plane of the plane polarized light towards right, and L is towards left. These two combinations are possible, right?
Yes, sir.
Okay, so if we have 50-50 ratio ka mixture of both of them in a sample, let's say we have a sample and 50% is the D isomer and 50% is the L isomer. Will the sample be optically active?
No.
Kaise yes hoga? It won't be. They will cancel each other.
So it
50%
won't
is
rotate,
rotating
and
right.
therefore it won't be optically active.
See, 50% is rotating the right towards right. The other 50% is rotating the right towards left. So they will counterattack themselves. So therefore, it is optically inactive. So this mixture is known as a racemic mixture. Yep. So this is known as a racemic mixture, and this process is known as racemization. Understood? Okay. Right. Okay. So next talk about retention, inversion, and racemization. Okay. Write down retention, inversion, and racemization. So what are these three? Okay. Okay. So observe everyone, retention, inversion, and racemization. It's important to understand what are these. Okay. So first observe, this is my starting compound. Observe everyone first. This is the compound that I am starting with. Is it chiral or achiral? Is it optically active or inactive? Come on, everyone. Online students, you need to
Can you
answer.
circle the one you're talking about?
Ye wala bhai.
It is chiral. 1 second.
Active है कि inactive है वो बोल दो.
If it superimposes, then it's optically inactive. So it's not super. So it is optically active.
Optically active है देखो. Look at this. This is your carbon, right? This is your carbon atom.
Yes, sir.
This is your ethyl group. This is
Yeah.
your methyl group. This is
Methyl.
your hydrogen, and this is your X. X is a halogen. So
Yeah.
all the groups are different.
Yeah.
Okay. So this is optically active. Okay. Now, can you tell me? Let's say this compound is let's say represented by 1. Okay. So 1 say I did something, then it became B. What is this process? 1 say it became B.
Inversion.
Process का नाम बेटा, process का नाम.
Oh.
We have studied this. नहीं, close. और क्या बचा है? SN2 guys, remember? The nucleophile comes and attack the carbon atom from behind, and the configuration changes. Guys, remember or not? Then revise, go and revise SN2. Go and revise SN2, everyone. What was SN2, guys? You have, okay, everyone. let's say you have OH. Okay, so this is the haloalkane that you started with. So SN1 is a type of mechanism of nucleophilic reaction. Remember nucleophilic attack.
Yes, sir. Yes, sir.
So let's say Cl minus आएगा, attack करेगा. कहाँ से attack करेगा? Which side?
With more this side.
Okay, so what will happen? You will get your answer as, remember, this was your SN2, remember, right? So can you observe a change in configuration? What is configuration? The way groups are attached to this particular carbon. What do you mean by configuration? I'm not talking about DL. I'm not talking about that. That is optical activity. Wo goli maro. That is different. I'm talking about configuration. Configuration is how are different groups present or they are in space. So see, this is a particular configuration. If you see here, the product, this is totally inverted, right? So this is known as inversion. Understood? Inversion means complete change in the configuration. So SN2 की वजह से what happens? Inversion. The product gets inverted. Write down. Due to SN2, the product that we are getting gets inverted, provided there is a condition. The haloalkane that you are starting with should be optically active, है कि नहीं? अगर ये optically active है ही नहीं, तो हम बोल, can we say that? Configuration is only when all the groups are different. ठीक है? Write down in SN2. Are you
So I
understanding?
can barely hear your voice.
Yeah, same here. Okay.
Due to SN2, product gets inverted. Sorry, yeah, due to SN2, product gets inverted, provided
the haloalkane, I mean the haloalkane that you are starting with is optically active. Yeah. So what can we do? You have earphones.
So I can't hear you.
अरे क्या करूं मैं?
Like when you're talking, when you move away from the laptop, your voice just breaks and I don't.
Everyone else, are you facing the same issue?
Can you change your microphone to the one on your laptop? It's like no, I meant to join through your laptop.
अभी सुनाई दे रहा है?
Yeah.
बढ़िया से?
Yeah.
मजा आ गया?
Yeah.
So when you move away from the laptop, your voice goes.
What about now?
Yeah, it's better. Like if you speak louder, I'll be able to hear.
क्या यार इतना बेसुरा आवाज है, जोर से सुनना है तेरे को?
No.
Why do you want to make your evening bad? Okay, I cannot do anything. You need to listen to me. Okay, bear me. Fine. So understood. So that was your inversion. Let's talk about retention. Now observe. So 1 से लेके now observe guys. 1 to A. 1 to A. See what happened. Is there a change in configuration 1 to A? No. Just X यहाँ से गया and then you got Y. Simple substitution. Is there a change in configuration? No. So this is known as your retention. Remember, there should not be no change in the configuration. Then it is known as retention. Someone close that door, no?
Only substitution is in retention.
It's simple substitution. I mean, it's just one group is coming and one group is leaving. It's neither SN2, it's neither SN1. Okay? It's retention. And see the conversion from 1 to A plus B. 1 to A plus B. Harshal, you started with 1, and after a process happened, then you are getting A plus B. That is equal mixture of A and B. What is that known as? Just now I told you. Racemization or a racemic mixture. So this is known as racemization. So what is this process? When do you get a racemic mixture? SN1. Whenever there is a carbocation formation, remember, guys, I told you carbocation is planar. So this is your carbocation, yaad hai? So this is in the plane. So this is in the plane, okay? So the nucleophile can come and attack. If it is attacking from here, you will get the D product. If it is attacking from here, you will get the L product. And there is a probability, equal probability. यहाँ से भी attack हो सकता है, यहाँ से भी attack हो सकता है. So you are getting equal chances. So you are getting a racemic mixture. So always remember, whenever there is SN2, there is inversion. You know what product you are getting. But what about the position in space? That will be inverted. Okay. And SN1, you are going to get a racemic mixture. You will get a combo of 2 products. Okay? Is it clear, everyone? Okay. Okay, so remember what were we initially, why are we discussing this SN1, SN2? What was that? Inversion, though it came later, right? What were we doing initially? Yes,
Retention and inversion and all.
yes, it is a mechanism of nucleophilic reaction. But what are nucleophilic reactions? Why were we discussing nucleophilic reactions? Remember?
Because it gets inverted. That's why you've written due to SN2 product, it gets inverted.
Yes,
That's
yes.
the reason you were saying.
Yes. We are talking, yes, Soham, you are correct. Lekin we are talking about reactions of haloalkanes. तो उसमें एक सब पार्ट आया था कि there are 3 kinds of reactions shown by haloalkanes. Remember? First one is nucleophilic substitution. दूसरा है elimination. Third one is reaction with metals. याद है? So first one is done. It took us a very small number, that is only 3 classes to complete. Okay? So next we are going to talk about elimination reaction. Okay, guys, this is very interesting. Elimination reaction. If you don't complete your homework, this will be your result. The PJ. Learning from Ashish sir. Okay. So next is your elimination reaction. So first you need to know what is the alpha carbon. I told you initially. What is the alpha carbon?
Alpha carbon.
No, I mean, why did you say that? Important to know, why did you say that? You are thinking something else. Bhai, that is Markovnikov, that is different. That is Markovnikov's rule. Yeah. Yes, Harshal. What is the alpha carbon? Okay. Good. Alpha carbon is the carbon which is linked to the functional group. याद रखना. Halogen valogen मत बोलो. सही है. But remember this, okay? So for example, CCCX, which is your alpha carbon? 1, 2, 3. Which is your alpha carbon? 1, right? So this is your alpha carbon. This is your beta carbon. This is your gamma carbon. याद है?
Yes.
Okay. Now, what about this? Yeah, tell me, where is the alpha carbon here?
It's 1 and 3.
Really?
Yeah, 1 and 3, 1 and 3.
Ex students.
1 and 3.
Yeah, 1 and 3, 1 and 3.
Ex students, Dhwani, Soham, and Harshal, proud of you.
So Pihu also said.
Someone left us in the middle. Priyal, तू ज़्यादा मत हंस, तेरे को ही बोल रहा हूँ मैं.
I know.
ठीक है? Okay. So remember, this is your functional group, guys. So this is the carbon that is linked to the functional group. Remember. So these are your alpha carbons, and this is your beta carbon. याद है? Okay. Fine. Okay. So now अब elimination देखो. Now, like, we are very lucky that you remember that nucleophilic reactions were shown by many of them. याद है? ROH, NH2, RNH2, RNH3, RCN. याद है क्या? Most of them were एक table था, याद है? There was a big table. All of them were showing nucleophilic substitution reaction. But elimination, we are very lucky. Only one guy shows them. Okay? So that is alcoholic KOH. This guy, whenever you see, in your mind, it should come that, okay, it is going to do elimination. Okay? There is one more guy, which is an imposter, that is aqueous KOH. This does nucleophilic substitution. I will tell you the reason. But remember this. Whenever you have aqueous KOH, you have then nucleophilic substitution hoga. If you have alcoholic KOH, it will show elimination. Alcohol not good for health, elimination. ऐसे याद कर सकते. See, the elimination is because of laziness. Okay, I will tell you, elimination is because of laziness. अब देखो क्या होता है? What happens in a, okay, I will tell you why are they showing different behaviors. Okay, first of all, do you understand what is alcoholic KOH? What is that? Huh?
The KOH. Oh.
What do you mean by
plus water? KOH plus water. Diluted KOH.
KOH in alcohol. You have ethanol as a solvent and KOH is dipped there. KOH is the solute. And ethanol या methanol, कोई भी alcohol ले लो, that is your solvent.
Solvent, yeah.
Okay, that is the meaning of alcoholic KOH. Aqueous KOH का क्या मतलब है? The solvent is
Water.
Water, right? Something which is not there in Rajasthan. Okay, in Bangalore also. Okay, now let's think about nucleophilic substitution again. What was it? So if you remember, you had H, X, Y, and Cl and KOH aqueous. So this is your reactant, yaad hai? Which, and this is your substrate, yaad hai? What will the reactant do? It will generate a nucleophile. Hi, this is a nucleophilic substitution reaction. So this guy will generate a nucleophile. What is the nucleophile that KOH generates? Good. So it will generate
OH minus.
Okay. So this OH minus is not lazy. It is very active. So it will go and attack this carbon from behind. Okay. But the problem with KOH alcoholic is this guy is very lazy. Instead of, again, I mean, instead of going and attacking, yeah. Okay, so here KOH is generating OH minus and OH minus is very active. That's why it is going and doing nucleophilic substitution. But the problem with KOH alcohol is that the nucleophile generated, we'll see which is the nucleophile. It is not OH minus, guys. Write down. The nucleophile that is generated in KOH alcoholic is not OH minus. It is not OH minus. Because if it was OH minus, then it can go and attack, no? It is not OH minus. We'll see what is that. So this guy is nucleophile generated is very lazy. Okay, now we will see which is that nucleophile. Okay, so if you remember last year, what was a base? What is the definition of a base?
There are many definitions.
See?
There are many definitions. Whose definition do you
तो हम
want?
जोर से बोलना.
So there are many definitions. Whose definition you want?
सारे बोल.
I don't remember Sare and all.
ठीक है, तो आता है वो बोल.
One was accepts H plus ions.
Good. Accepts H plus ions. Yes.
One was gives away
Gives away.
gives away OH minus or has OH minus.
In terms of electron.
It has electron.
Lewis base. याद है?
Yeah.
What is a Lewis base? Gives away electron. What is a Bronsted base? Accepts H plus.
H plus. Okay.
Right? You need to know these things. Okay. Lewis acid क्या करता है? Accepts electron. And Lewis base is donates electron. Donates electron. ठीक है? Lewis acid accepts electron. Lewis base donates electron. Okay. Now let's see what happens in KOH alcohol when it is in an alcoholic medium. Okay. So let's say I'm representing the alcohol as ROH. Can I do that? Okay. So what I'm doing, observe everyone. So here what will happen? This will normally dissociate into K plus and OH minus. Okay. But medium क्या करेगा? Now the ROH will combine with the OH minus. Are you getting what is happening? KOH will split, it's an ionic compound. So it's going to split normally, K plus and OH minus. But there is a alcoholic medium. So that ROH, that alcohol is going to react with this OH minus to form RO minus and H2. Does it make sense? Is the reaction balanced? Check करो सब लोग, charge balanced है, atom balanced है, check करो.
Yes, sir.
ठीक है? So which is the nucleophile that is ultimately being generated? RO minus.
RO minus.
ठीक है? This is not OH minus. So remember, whenever you have KOH alcoholic medium, the nucleophile is RO minus. This nucleophile is lazy. You will understand why. Lazy, or you can say more powerful. तो कुछ करने की जरूरत ही नहीं है उसको. All the inventions are done because of laziness, if you know that. ये सब Amazon, Flipkart, Zepto. Okay. So this RO minus is a lazy, or you can say a more stronger nucleophile than OH minus. Okay. So let's see why. Let's see RO minus and let's see OH minus. ओके पहले तो इसका नाम क्या है? इसका नाम क्या होता है? OH माइनस का नाम क्या है? हाइड्रोक्साइड आयन. ठीक है, रिमेंबर हाइड्रोक्साइड आयन. RO माइनस का नाम लिख लो, एल्कोक्साइड आयन. Alco, that name is coming from R. R is the alkyl group, right? So that's why alkoxide है. Alkoxide है, ठीक है? Okay. Now, you tell me one thing. How will you decide that a particular, if you want to compare 1 and 2, which is a stronger nucleophile, how will you decide? किसके पास ज्यादा electrons? Which has more intensity or density of electrons. That will be a stronger nucleophile. है ना? Now you tell me OH minus has more electrons or OR minus has more electrons. Think in terms of effects, inductive effect.
Does OR have more electrons?
OR minus, who are saying OR minus? Okay, so it is OR minus because R is the electron donating group. So it is giving its electron to this oxygen, जिसकी वजह से ऑक्सीजन के पास बहुत सारा इलेक्ट्रॉन compared to OH minus. So OR minus is stronger. Okay, so this is the first step in elimination. First step in elimination is creation of a nucleophile, that is RO minus. Okay, now what will happen? Everyone observe. See this point, for a haloalkane to undergo elimination, we need beta hydrogen atoms. That is the requirement. There is a requirement of beta hydrogen atoms. Always remember that. If you want an elimination reaction, there is a requirement of a beta hydrogen atom in the haloalkane. ठीक है, beta hydrogen चाहिए. You will understand why. And this reaction is also known as beta elimination. Elimination है ही है, but it is known as beta elimination for a reason. Because you'll come to know. Give me some time. This is also known as beta elimination reaction. ठीक है, अब देखो क्या होगा. अब अपने पास OR minus generate हो गया है. ठीक है, so let's say it is going to attack. So let's say that अभी this is our nucleophile, और मान लो कि ये अपने पास जो है ये है अपना substrate which is alkyl halide, right? Alkyl halide. तो मान लो कि let's start with this. Will this show elimination? Everyone, will this show elimination? No. प्रियल, स्क्रीन में क्यों नहीं देख रही है तू? नहीं, वो दिखाने नहीं बोला, मैं बोल रहा हूँ स्क्रीन में देख. सो हम
I don't know.
ये वाला पॉइंट पढ़ एक बार. फॉर ए हेलोअल्केन टू अंडरगो एलिमिनेशन वी नीड बीटा हाइड्रोजन एटम्स.
Okay, so it will go elimination.
Where is
this
beta hydrogen?
This is alpha. No, this is not even alpha. I don't know what it's called, but it's not beta hydrogen.
Dhoni,
It won't undergo elimination.
it is not going to undergo elimination because there is no beta hydrogen. There is no beta carbon, first of all. This is your alpha carbon and these are your alpha hydrogens. The hydrogen which is attached to the alpha carbon is known as alpha hydrogen. Simple. So it is not going to undergo beta elimination. Remember. ठीक है? So then what will happen? If OR minus आके attack मारा तो क्या होगा? It will undergo substitution. Very good. Because elimination हो ही नहीं सकता. So what is left? तब you have to do something, right? So then it will undergo substitution. Your answer is CH3 OR. खत्म. So it is a ether. Your answer is a ether. Understood? Very, very, very important. अब मान लो कि बीटा हाइड्रोजन है अपने पास. Then the scenario will change. So let's say I have, yes, will it undergo elimination? Soham, will it undergo elimination?
No.
क्यों भाई? बीटा हाइड्रोजन है ना.
Okay, fine.
अल्फा कार्बन है, ये बीटा. तू सुन रहा है कि नहीं? तू ध्यान दे रहा है कि नहीं क्लास में?
Sir, I understood. I thought that. But it's. Didn't we just do? Oh, it's. Oh, my bad. Oh, I saw it wrong. Fine. Okay. I thought that we'll call the. Okay, I understood. Okay.
ठीक है.
So I'm telling. I thought that the alpha.
मैं समझ गया. Okay, so this will undergo elimination. Remember, because there are 3 beta hydrogens and all 3 are equivalent, so you'll get one product. ठीक है? तो अब देखो OR minus being a strong base, nucleophilic substitution में क्या हो रहा था? OR minus was coming and attacking the alpha carbon. यहाँ पे नहीं करेगा वो. It is lazy. It will take a hydrogen from here. ये hydrogen उठा लेगा. Hydrogen जाने वाला है उसके पास. I told you it is more powerful. It is lazy. So this hydrogen is going to this OR minus. This is elimination. Okay? So this hydrogen will go and combine with this OR minus. Okay? So there will be some electrons left here, right? 2 electron left होगा. Guys, if this goes, it become H plus, right? So यहाँ पे 2 electron, ये यहाँ पे आके double bond बन जाएगा और ये Cl उड़ जाएगा. So your answer will be CH2 double bond CH. कुछ गलती हुआ है ना? No, there is one more hydrogen. CH2 CH. Understood what happened? Again, I will repeat. Okay, everyone focus. Now the nucleophile is stronger, so there is no need for it to come and attack now. No need of that. That happens only in nucleophilic substitution. Instead, now what will happen? It will extract a beta hydrogen. कि भाई beta hydrogen वो उठा लेगा, kidnap कर लेगा उसको. तो ये hydrogen गया. So it will become a H plus. ठीक है? H plus की वजह से, so these two will combine and form HOROH alcohol again. And यहाँ पे electron pair free है ना? So this will come and form the double bond, and ये Cl फिर निकल जाएगा. So you'll get a alkene. So your final answer is a alkene. Write down, everyone. Whenever elimination happens, we always get alkene. Whenever elimination happens, we always get alkene. अब आओ मेरे पास, रह जाओ मेरे संग, समझे. ROH. Cl, हाँ, और Cl माइनस निकल जाएगा. न्यूक्लियोफाइल है ना, एक न्यूक्लियोफाइल है, दूसरा न्यूक्लियोफाइल गया. तेरे को याद है क्या हर्षल, जब हम लोगों ने KOH लिया था तो K प्लस और OH माइनस किया था, याद है? तो ये K प्लस क्या करेगा? मच्छर मारेगा. ये KCl बनेगा. ठीक है? Okay. Understood. Okay, now let's make the situation a bit more complicated. Okay? Because life is unfair, always remember. Just, I will give you an example. This you should try, okay, everyone? CH3, CH2, CH2, CH, Br, CH3. Okay? And you are reacting this with alcoholic KOH. Come on, tell me the answer. Tell me the answer. First of all, decide which reaction. Alcoholic KOH दिख रहा है, close your eyes, it is going to be elimination. Oh, one more thing. Also check for beta hydrogens. There are beta hydrogens, yes or no? There are. Okay, so elimination. Now find out the answer. चाणक्य है क्या? है ना? नीचे क्या पहना है? नीचे क्या पहना है? वो ताश के, हाँ, वो चाणक्य को तो छोड़ दो. पार्टी का बर्थडे में तो सिसियाना में पार्टी चाहिए भाई. ठीक है? अकेले Okay, done. Got the answer. Beta hydrogen will be removed and the halogen will be removed and you will get an alkene. Simple. Online students, send your answers in the group. Got it? Got it? Huh? Got the answer on? Correct. It's correct. Yeah, it's correct. But this is one of the product. Show me your answer. You will get multiple products. Just giving me a hint. Yeah, he got the other product. So you are like a racemic mixture. CH2, CH, yes, correct. You got the other answer. So both of them will be formed. But out of those two, there is one major product. Major product, you mean, you understand that, right? What is a major product? In Markovnikov, you get a major product. The other product is also possible. Guys, what was Markovnikov? Negative attacks the carbon with least number of hydrogen. याद है? करेक्ट. तो इसमें से मेजर प्रोडक्ट कौन सा है बताओ? मेजर प्रोडक्ट बताओ. कैसे? So how will it make it a major product? Correct answer, correct. But why is that the major product? Lesser number of hydrogen से क्या होता है? कैसे? Surface area physical property. क्या सेकेंडरी? Who attacks? ये प्रोडक्ट बन रहा है. So who is attacking? Beta, is there carbocation formation? Then guys, first of all, observe all the different beta hydrogens. Okay, this is your beta hydrogen. This is your beta hydrogen. So you will get the different kinds of beta hydrogen you get. That many number of product that you are going to get. समझे? So you will get two products. So let's say this is your beta hydrogen 1. This is your beta hydrogen 2. So let's talk about 1 now. 1. So what will happen? So let's write CH2 like this. H यहाँ से जाएगा, H यहाँ से जाएगा. So what will happen? This hydrogen will go out. ये double bond बनेगा. And this Br will go on. So your one product is CH3, CH2, CH, double bond, CH, single bond, CH3. Got it? This is one of your product. फिर क्या होगा देखो? वापस लिखो इस कंपाउंड को. ओरिजिनली कैसा था? ये था ओरिजिनल कंपाउंड. Then let's talk about 2. If 2, तो यहाँ से इस I am rewriting it again just to show you. CH, H, H. So what will happen? The base will come and extract any one of the hydrogen. So एक hydrogen उठा लेगा. So what will happen? That hydrogen will give this and form a double bond here, और ये Br निकल जाएगा. So you will get CH3, CH2, CH2, CH, double bond, CH2. So these are the two alkenes that you are getting as your answer. ठीक है? But one of them is more stable than the other. How will you decide that? So you have something called Saidzev's rule. Write down Saidzev's rule. Saidzev's rule. To decide the major product formed in a elimination reaction, we have Saidzev's rule. Guys, if you are getting only one product, then there is no need of Saidzev's rule, right? You are getting multiple products here. देखो पहले जब मुझे ये मिला था, याद है क्या? CH2 मिला था. Did I use Saidzev's rule? I got only one product, so no need to worry. Here I am getting more than one product, so I have to use Sidzev's rule. ठीक है? हाँ, तुमने क्या बोला था हर्षल? Second one is okay. So write down Sidzev's rules. Sidzev का जो rule है, write down. Alkene which is more substituted. Alkene which is more substituted is more stable. Alkene which is more substituted is more stable. So you tell me which alkene is more substituted here, 1 or 2?
1.
1. Yes.
Wait, sir, I don't understand what more substituted means.
That you should have asked me. Okay. More substituted का मतलब होता है, okay, everyone, observe. ये वाला alkene सबसे basic alkene, there is no substitution at all. CH2 सबसे basic alkene. If I remove one hydrogen and I replace that by CH3, so this is substituted compared to CH2. If I add one more alkyl group, for example, CH2 double bond C, CH3. This is more substituted than this. So you understand what is the meaning of substitution. If the hydrogen attached to the doubly bonded carbon is replaced by alkyl group, then it's a substituted alkene. Okay? So यहाँ पर देखो, this alkene has how many carbon atoms? 1 and 2. 3 hydrogen atoms. इस वाले alkene के पास कितना है? 1 or 1, 2. Only 2 hydrogen. So which one is highly substituted? The first one. First one has only 2 hydrogens.
If you say the further away the product is getting, the one that is further away, you see actually.
नहीं, ऐसे नहीं बनना, ऐसे मत बोलना. ये लिखना मत. अपने समझ के लिए you can write it. Or you can say alkenes in which there is lesser number of hydrogen atoms which are directly attached to the doubly bonded carbon is a more substituted. I hope you understood. If anyone have a doubt, you can ask.
So the first one is more substituted, right?
Yes. First वाले के पास बस 2 हाइड्रोजन.
Okay.
Second वाले के पास देखो 3 हाइड्रोजन है. C double bond C में. Clear? Is it clear, everyone? Any doubt? तूने first बोला था, second बोला था? Okay. Fine. So go to your exercise. Do question number 6.22. Abhi karo. Giving you 10 minutes. 6.22. Do question number first, the first subpart, and the fourth subpart. First, fourth, and also sixth. Easier. Come on. First, fourth, and sixth. Come on. You should be able to answer. I will share the videos, okay, today in the group. You need to go through all of them before Monday. Okay, you have
So can
holidays
you
going
repeat
on,
the
right?
questions again?
One second. Holidays, so you can give time, okay? All the lectures I'm forwarding. Bol.
Can you repeat the questions again?
Okay. Do you know any one of them? Any one of them? No one. You know Soham? ठीक है. अरे Soham.
Who?
And then how will I give you?
Who knows me?
उसका नंबर है क्या तेरे पास?
Who?
I don't remember your name. Firaz.
Oh yeah, I have Raz's number. Yeah.
उसका नंबर है तेरे पास? ठीक है. सुन. I am forwarding you some videos, तो उसको forward कर देना.
Okay.
भूलियो मत.
Okay.
अभी मेरे को एक मैसेज कर, तो सोहम ऐसे करके कि सर वीडियोस, ऐसे मेरे को एक मैसेज कर. गॉट इट? हाँ प्रियल, क्वेश्चन था 6.22 का फर्स्ट, फोर्थ एंड सिक्स्थ. First one is N-butyl chloride is treated with alcoholic KOH. Which reaction is that? First of all, elimination. No, first check N-butyl chloride whether it has beta hydrogens or not. So let's check N-butyl chloride. N-butyl chloride is very simple. This is your N-butyl chloride. So does it have beta hydrogen? Yes. This is your alpha carbon. This is your beta carbon. How many products are possible? एक ही है, देखो, एक ही है. Only one product. How many beta carbons are there? Only one. Okay. So what will happen? You will get this hydrogen is going, this fluorine is going. You will get CH double bond CH2. This is your answer. Got it? Plus ROH plus KCl. हाँ, so हम बोल.
So what are the questions? People was asking me.
6.22 first, fourth and sixth.
Okay.
Priyal understood? Dhoni understood? अभी फोर्थ वाला देखो, इथाइल क्लोराइड, वेरी सिंपल, 3 carbon atom, aqueous KOH. Guys, what is the answer? Simple substitution. Simple substitution. SN1 की SN2. SN2. It is primary. Remember. This is your answer. ये फोर्थ वाला. Then sixth one. हाँ. समझ जाना भाई, समझ जाओ, ठीक है, बाय मिस्टेक. हर्षल जान लेगा, बच्चे की जान लेगा. I want to say how Harshal will teach. लास्ट डे तू पढ़ाएगा, बायोमोलिक्यूल्स होगा लास्ट चैप्टर, तू पढ़ाएगा. पहले तो तू टाइम पे आना सीख जा. ओके, देन सिक्स पार्ट, मिथाइल क्लोराइड, okay, is treated with KCN. Guys, what will be the answer? Which reaction is this? First of all, substitute nucleophilic. Don't say just substitution. Substitution can be electrophilic also. Nucleophilic substitution. SN1, SN2. Why is there a doubt? It's a primary carbon. Primary carbon will always show SN2. Tertiary carbon will show SN1. So the mechanism is SN2. What is the answer? CN की NC याद है? CN है. For AgCN वो NC होता है. क्या same thing? How is it same thing? Your answer is this. Your answer is CN. But if it was AgCN instead of that, remember CN is a MB10 nucleophile. Guys, अगर AgCN होता तो your answer will be CH3NC, isocyanate. ठीक है? If you have a doubt, you can ask me.
Yes, and the secondary one can give you any, I mean, they can go through, depending on the circumstances, they can go through SN1 or SN2. Okay. Okay. Next, write down reactions with metal. Reaction with metals. Third one, reaction with metals. Reaction with metals. Okay. Under that, first write down क्या था क्या ये organometallic compounds. Organometallic compounds. ठीक है. Organometallic compounds. Definition लिखना. Compounds containing carbon metal bonds. Compounds containing carbon metal bonds. Okay, wherever you see carbon metal bond, those compounds are known as organometallic compounds. ठीक है? Organometallic compounds. Example के लिए देखो CH3 MgCl. Is there a bond between carbon and metal here? There is a bond between, so this is your CH3 और यहाँ पे Mg, ये plus ये Cl minus. You understood what I did? Ah, wow. Okay. So there is a bond between carbon and metal here. So this is an example of a organometallic compound, right? So there is a specific example RMgX. These guys are known as Grignard reagent. I am telling you, very important. I am telling you, in further organic, you will encounter them. Okay? You will encounter them. Those are very important.
Can you repeat that? I didn't understand.
Okay. Arush, close the door, close the door. Close the door. Huh?
Sir, can you repeat the RMGX part? I didn't
हाँ
understand.
बेटा सुना मैंने, एक सेकंड रुको.
Oh,
Okay. Close the door. ठीक है. तो again I will repeat. Okay. So first we need to know what are first we need to know what are organometallic compounds. ठीक है. So whenever those compounds which have a carbon and metal bond, though if they have a carbon metal bond, then it is known as a organometallic compound. ठीक है. उसका मैंने एक एग्जांपल दिया, फॉर एग्जांपल CH3 MgCl. यहाँ पे देखो कार्बन और मैग्नीशियम के बीच एक बॉन्ड है, देखो. So this is an organometallic compound. ठीक है. Now there is a specific group. These are also examples, and these have a specific name. So these are known as Grignard reagent. Grignard reagents. Okay, RMgX. So whenever I ask you what are Grignard reagent, you should be able to tell me RMgX. What is R here? Alkyl group. Mg is magnesium. X is a halogen. Okay, X is a halogen. So next लिखना, next write down. एक क्वेश्चन लिखो. How do we obtain Grignard reagent? How do we obtain Grignard reagent? आप उसको मत पढ़ाइए, बाकी सबको पढ़ाइए. ठीक है. Don't laugh. It you know it support करता है उसको, और करने लगता है. तुम लोग हंसते हो ना, उसको और he gets the fuel. Okay, don't do it. Okay, so Grignard reagent, how will we get Grignard reagent? तो write down कैसे होता है, पहले देखो. We take Rx. What is Rx? Rx is alkyl halide. We react that with magnesium. in the presence of dry ether. You know what are ethers, right? What are ethers? हर्षल स्मार्ट तो है, बच जाता है इसीलिए, नहीं तो मैं रोस्ट बहुत करता था. ठीक है, so you will get RMgX. How will we obtain Grignard reagent? We have haloalkane, we react that with a metal Mg and we get RMgX, which is a Grignard reagent. ठीक है, okay, which is a Grignard reagent. Write down one more point about them. Grignard reagents are highly reactive. ये point is very important. ऐसे स्टार मार्क लगाना है. Grignard reagents are highly reactive and react with any source of proton. And react with any source of proton to give you hydrocarbons. To give you hydrocarbons. This is very important. Example देखो. So RMgX. So this is your Grignard reagent. Remember everyone, RMgX is your Grignard reagent. So this guy is very reactive. Okay. So it reacts with any source of proton. कहीं से भी अगर proton मिल गया, for example जैसे मान लो H2. मान लो H2O से एक proton उसने उठा लिया. So what will happen? ये R इस एक H के साथ combine कर लेगा to form RH. Guys, what is RH? What are RH? Alkane. Hydrocarbon alkane, and then you will get MgOH X. Understood? These are the two products that you are getting. So they can react with either water or alcohol or amine, any three of them, to give you hydrocarbons. This product can be different, but hydrocarbon तो मिलेगा ही मिलेगा. ठीक है, तो Grignard reagent react with water or alcohol or amine to give you hydrocarbons. Remember that. Okay, the side product can be different. Now write down a question. Convert. ये question बहुत आने वाला है. This question is going to come. They are not going to ask you directly. कि अरे RX plus Mg, what will you get? RMgX. No. So convert N-butyl halide to butane. Convert N-butyl halide to butane. Okay. So just a tip before you do this, whenever you get conversion questions, first of all, draw whatever they have given in words. So what have they given you? N-butyl, क्या बोला, halide. So make it chloride. Make it chloride. Let's be more specific. So what is N-butyl chloride? So it is CCCCl. So draw that first. So this have to be converted to butane. Butane is CCCC. Okay, first do this. Whenever you get these type of questions, you will get, if the invigilator is in a good mood, you might get half marks, which I am not. Okay. Come on. It will give you clarity. Where to start with, where to end with. I checked your papers, no? Yeah, I checked your papers. You want to see? Tremendous performance. नीचे से. How will you do it? Kshitij. Use your brain, man. Just now I taught you something. अभी पढ़ाया था. Not even one page behind. Why did you learn Grignard reagent? Use it. तू क्या कर रहा था? I want to know. नहीं नहीं नहीं, उससे गलती पता चलेगा क्या कर रहा था।
मैंने अल्कोहल फ्लेवर से देखा।
ठीक है, तो उससे एल्कीन मिलेगा ना। हाँ
उसको मैंने एक्टिव ऐड
ओके, करेक्ट है, एक्चुअली करेक्ट, एक्चुअली करेक्ट, ऐसे भी कर सकते। वाह,
So you convert it to alkene first and then to alkane.
yes, he converted it to alkene, then you can do Markovnikov's addition of water. एक सेकंड, अगर मार्कोनिकोव एडिशन किया तो OH जाके अटैक करेगा ना, H2 ऐड किया है। हाँ ठीक है, करेक्ट, दिमाग तो है भाई हर्षल, हर्षल का दिमाग तो है। Use Grignard reagent. I will also explain how can you use Markovnikov's addition. Yes, yes. First add Mg. This is alkyl halide, guys. Alkyl halide में Mg add करने से क्या होता है? You get Grignard reagent. याद है? RMgX. So here, if you add CCCCCl plus Mg, you will get CCCCMgCl. This is the first step. Then if you remember, RMgX are very, very reactive. If you add it to water, what will happen? They become RH. So add this to water. So what will happen? This will become CCCCH. Finish. There is no need to write in one step. You can use multiple steps. Show each and every step properly. Okay. You are going to get these type of questions. और जो हर्षल ने किया है, हर्षल ने क्या किया है देखो, CCCCL. He reacted this with alcoholic KOH. ठीक है, एल्कोहलिक KOH के साथ रिएक्शन करोगे तो क्या होने वाला है, बीटा हाइड्रोजन जाएगा और ये Cl जाएगा और एक डबल बॉन्ड आएगा, सो C डबल बॉन्ड C, एल्कीन मिला, देन ऐड हाइड्रोजन. व्हाट इज दिस प्रोसेस नोन एज हाइड्रोजनेशन, याद है? व्हाट विल हैपन? फिनिश. हाइड्रोजन एक यहां आ गया, एक हाइड्रोजन यहां आ गया, डबल बॉन्ड से सिंगल बॉन्ड में. दिस इज आल्सो गुड. कर दिया. लास्ट पेज बोलना.
Yeah.
अंडरस्टूड? मजा आ रहा है कि नहीं? It's better than physical, right? No. Let me ask you a formula then.
It is definitely better than physical.
Okay. Tell me the relative lowering of vapor pressure formula. Come on. Who remembers it? Yeah. Oh, the first colligative property. So हम बोल.
So is it XB?
Okay, XB is equal to what? Correct.
XB is equal to the mole fraction of the solvent.
नहीं वो मुझे पता है, but what is relative lowering in vapor pressure? What is that exactly?
Oh, 1 second, let me think. So the lowering of vapor pressure is basically original vapor pressure, which is the undisturbed, I forgot the word for it, the raw vapor pressure, which is A naught, minus the problematic one, which is A, divided by the original one, undisturbed A naught.
Correct. P naught minus P divided by P naught is equal to XP. याद है? This is your relative lowering in vapor pressure. Okay. But you have to use I also. Don't forget. There is a I.
So that's when you have that Van 't Hoff. No, otherwise you don't need it.
That is, so real life में क्या होता है? Van 't Hoff भी आएगा ना? ये तो ideal case में है. ठीक है, कोई बात नहीं. ऐसे में hero बनना. Okay. Then what do we have? अच्छा लग रहा है. बहुत दिन से हेलोएल्केन चल रहा है. Like खत्म क्यों नहीं हो रहा है ये चैप्टर? अभी भी है. Okay, then write down Wood's reaction. In reaction of metal itself, you have Wood's reaction. This you need to know. You remember, I taught you last year. Wood's reaction. Wood's reaction. This is under reaction of metals. ठीक है? There are three reactions: nucleophilic, elimination, or reaction of with metals. So उसमें ही है ये Wood's reaction. What was Wood's reaction? रियल को क्या हंसी आता है भाई, इतना घटिया लग रहा हूँ क्या?
So I thought it was Vert's reaction all this time. Was it not Vert's reaction?
कुछ भी बोलो यार,
I've been calling it. I thought it was Vert's reaction.
आंसर बता.
Vert's reaction was in the beginning of the chapter. Wood's reaction. I have no idea. I've never heard of it.
हाँ ध्वनि आंसर बता.
Not sure, but is it when the alkyl halide reacts with sodium in dry ether and gives hydrocarbon?
Correct. हाँ correct है, correct है. Anyone else want to try? Those who were present last year. हाँ वो Kolbe है, Kolbe's reaction है. Wood's reaction is Rx plus 2Rx plus 2Na will get Rr plus 2NaX. This is your Wood's reaction. Okay. So this is the alkyl halide and you are reacting this with a metal which is sodium. दो molecule लिया था 2Rx plus 2Na, you are getting Rr, दो close कर, ठीक है, और 2NaX. This is your Wood's reaction. ठीक है, clear? Write down everyone. I don't know how it is pronounced. Words तो अच्छा नहीं लगता सुन के.
I know that, so I've been mispronouncing it. That's why I was laughing. And also because his name is funny. It's like Fajans.
Fajan is my boy. Fajan. Fajan's rule. किसको किसको याद है Fajan's rules? Yeah. What is it for? Just tell me that. It's for bonding of what? Huh? Carbon. नहीं. Not every bond is correct. Okay. Okay. Fine. Next, write down. So, if you remember, we were talking about reactions of haloalkanes. Did we talk about reactions of haloarenes? Okay. We did not talk about reaction of haloarenes. So, write down reactions of haloarenes. Whatever we have discussed till now, these are the reactions of haloalkanes, not of haloarenes. Haloarenes are quite different from haloalkanes. I have told you this. Okay. So, ये पहले टॉपिक लिखो रिएक्शन ऑफ हेलोअरीन्स, उसके नीचे लिखो 5 mark क्वेश्चन which is going to come in your exam. 5 mark question which is going to come in your exam, any one of the exam. It can be your unit test or it can be your final board exam. आएगा ही आएगा, नहीं तो we won't talk. ठीक है, तो लिखो पहला पॉइंट लिखो एराइल, वो क्वेश्चन लिखो, उसमें पहले ऐसे लिखना न्यूक्लियोफिलिक सब्स्टिट्यूशन. दे डोंट शो बट लोग लिख रहे हैं, मैं बताता हूँ. ठीक है, तो उसके नीचे एक क्वेश्चन लिखो, व्हाई आर हेलोअरीन्स और एराइल हैलाइड्स, व्हाई आर हेलोअरीन्स और एराइल हैलाइड्स extremely less reactive towards nucleophilic substitution reactions. क्या हो गया? There are 5 reasons. There are 4 reasons. ठीक है, each and every reason को ध्यान से सुनो, पक्का आने वाला एग्जाम. Why are haloarenes or aryl halides very less reactive towards nucleophilic substitution reactions? Yes, this is the question that they will ask. Then write down answer first point. उसमें लिखना resonance effect. First point answer में लिखना resonance effect. Okay. Now, everyone, we are in for a ride. Do you know what is resonance? I told you in I told you this. What was resonance? Movement of. हाँ बोलो बोलो बोलो. कोई भी बोलो.
Electrons.
So हम.
Movement of shared pair of electrons of the pi bonds, pi electrons.
Okay, you need to be specific. It's the movement of pi electrons or lone pairs. Write down. इलेक्ट्रॉन नहीं बोलना है, उसमें सिग्मा इलेक्ट्रॉन भी आ जाएगा. सिग्मा इलेक्ट्रॉन मूव कर सकता है?
No.
नहीं, सिग्मा इलेक्ट्रॉन मूव नहीं कर सकता. क्यों नहीं कर सकता? बिकॉज द ओवरलैप इज इफेक्टिव. कैसे? ऐसे बढ़िया वाला ओवरलैप होता है. रिमेंबर, व्हाई विल दे मूव अराउंड? दे आर टाइटली अटैच्ड. द पाई इलेक्ट्रॉन्स आर इजीली अवेलेबल, so they can move around. So resonance is the movement of pi electrons or lone pairs in a conjugated system. This word is baba kitna important. Conjugated system. Even if you have pi electrons or lone pairs, मान लो system conjugated ही नहीं है, तब resonance होगा ही नहीं. What is a conjugated system? Double, single, double. Double, single, lone pair. Double, single, बस. Okay. For example, जैसे देखो C double bond C double bond C. So what is there a possibility of resonance here? So this bond can come here, this bond can come here. So you will get C double bond C, single bond C double bond C, C. These are two different resonance structures, right? Okay. Okay. Now write down a point. Haloalkanes do not show resonance, but haloarenes show resonance. That's one reason why there is a difference in reactivity. Haloalkanes do not show resonance. Haloarenes show resonance. Can you tell me why haloalkanes do not show resonance?
Because they are alkane A, so therefore they cannot be pi electrons.
Correct. They neither have pi bonds, they neither have lone pairs. The halogen atom has lone pairs, but there is no conjugated system. Okay? Good. But haloarenes, they will show resonance. You will understand. First of all, you need to know what are haloarenes. If you remember, benzene ring में directly लगा हुआ है. The chlorine is directly attached to the benzene ring. These are known as your haloarenes. Okay, so they will show resonance and draw their structure properly. I am drawing you the different resonance structures. First of all, observe how many lone pairs does chlorine have in this structure. Does chlorine have a lone pair or not? How many? 3 lone pairs. How do you know that? Correct. Octet पूरा होना चाहिए हर एक एटम का. Chlorine has now only 2 electrons. बाकी के 6 कहाँ हैं? Lone pairs. 1 2 3 4 5 6. Important. Okay. So everything has a reason. So there are 3 lone pairs. So what is resonance? Movement of lone pairs or pi electrons. So what will happen? This lone pair will come here and this pi bond will come to this atom. This you need to remember. कोई logic नहीं है इसके पीछे. So you will get a resonance structure. Resonance structure कैसे दिखाना है? देखो, see the arrow. See this arrow. They are showed like this. This is not the equilibrium arrow. So what will happen? See here, everyone. This lone pair will become a double bond, and this pi bond will become a lone pair. Understood? So you will get double bond here, 2 electron pair, और यहाँ पे electron, और यहाँ पे ये. Everyone observe. Does it make sense? Lone pair आके bond बन गया, और ये bond बन के lone pair बन गया. This is one of the resonance structures. And there are charges also. How will you calculate the charge? Formal charge. What is the formula? Chlorine का निकालना है मेरे को. कैसे निकालूंगा? Valence electrons 7 minus how many electrons are there in bonding? 2. Chlorine ने कितना दिया है? 2 दिया है ना? और how many are present as lone pairs? 4. So what is the charge? +1. तो यहाँ पे प्लस चार्ज है क्लोरीन के पास. ठीक है. अब इस कार्बन में चार्ज देखो. ये वाला कार्बन में कितना चार्ज होगा? कैसे? शुड बी न्यूट्रल, राइट? अरे ओरिजिनली कोई चार्ज था क्या मॉलिक्यूल? सो ओवरऑल चार्ज हियर शुड बी 0. सो जस्ट क्लोज योर आइज एंड राइट नेगेटिव. Are you getting? The original structure did not have any charge, so the new structure also won't have any charge. Or you can calculate also, calculate कर लो. 4 minus how many electrons in bonding? एक और एक हाइड्रोजन भी है बेटा, 3 और 2 लोन पेयर, तो इसलिए -1. ठीक है. ओके, नाउ व्हाट विल हैपन? ये वाला इलेक्ट्रॉन हाई बाय, ये वाला इलेक्ट्रॉन ये आएगा यहाँ पर, ये वाला इलेक्ट्रॉन जाएगा यहाँ पर. ध्यान से देखो सब लोग, ये बहुत इंपॉर्टेंट. एंड लुक एट द पोजीशन वेयर यू हैव द नेगेटिव चार्ज गाइस. ऑर्थो पोजीशन में है कि नहीं नेगेटिव चार्ज? देयर इज अ, in the ortho position there is a negative charge. Okay, observe. So this is 1 2, something we are going to discuss later, which you'll appreciate. Now next structure will be Cl plus. ठीक है, अभी देखो यहाँ पे ये pi bond बन गया और यहाँ पे लोन पेयर आ गया, नेगेटिव चार्ज आ गया. Is this correct? Is the third structure correct? Everyone check once. Correct. Is there a charge in meta position? Is there a charge in meta position? Negative charge in meta position? No. Okay, remember that point. There is no charge in the meta position. बाद में you will appreciate this point. चार्ज कहाँ पर है देखो, ऑर्थो और पैरा में चार्ज मिलेगा. ठीक है, और एक स्ट्रक्चर है देख लो, ये आ जाएगा यहाँ पर और ये आ जाएगा इसके पास. So your fourth structure is understood, everyone? Why is the arrow? It is what it is. Wow. Correct. Are they in equilibrium? Yeah. Then what is tautomerism? Okay, again चार्ज कहां पर आया देखो, ऑर्थो पोजीशन, मेटा पे नहीं आया चार्ज. So this is your fourth structure. अभी फिर क्या होगा देखो, this will go back here, this will go back here, and you will get back your original guy. Life is complete. Okay. So actually chlorobenzene, this is chlorobenzene, this has 4 different resonance structures, and in 3 of them, everyone, and in 3 of them I am circling them, 2 3 or 4 में, what is the bond between C and Cl? Single bond or double bond? C और Cl के बीच कौन सा बॉन्ड है? 2 3 और 4 स्ट्रक्चर, there is a double bond. Okay, there is a double bond. Write down this point. Out of the 4 resonance structures, 3 में 3 have a double bond between C and Cl. Real video off क्यों है? And where is Dhwani?
So Dhwani went missing 10 minutes ago.
Okay. Second, third और fourth structure में ध्यान से देखो, there is a double bond between C and Cl. Okay. Out of 4 structures, 3 have a double bond. Now, what is a nucleophilic? Now everyone observe. न्यूक्लियोफिलिक रिएक्शन क्या होता है? ये वाला बॉन्ड टूटता है ना सी और Cl के बीच. ठीक है, तो कौन सा इजी रहेगा? डबल बॉन्ड होने से इजी रहेगा या सिंगल बॉन्ड होने से इजी रहेगा? व्हिच इज मोर इजियर टू ब्रेक? व्हिच इज इजियर टू ब्रेक, सिंगल बॉन्ड और डबल बॉन्ड?
Double bond.
Single bond.
Oh yeah, wait.
Double bond is more difficult to break. Write down. I mean, the bond strength is like this. Double bond is more difficult to break compared to a single bond. So, did you understand why haloarenes don't show nucleophilic substitution? Because the bond between C and Cl have to be broken. Yes or no? लेकिन haloarenes में there is a double bond. रेजोनेंस की वजह से. यहाँ पे कोई रेजोनेंस नहीं, यहाँ पे प्योर सिंगल बॉन्ड है, which is easier to. This you need to explain properly. सारे स्ट्रक्चर बनाना, draw all these structures, then you have to write down in majority of the structures there is a double bond between C and Cl. This double bond is difficult to break. Hence, haloarenes या alkyl aryl halides, they don't show nucleophilic substitution reaction. This is the first reason. Is it clear, everyone? क्लियर है? फर्स्ट रीजन क्लियर. सोहम प्रियल क्लियर है? सेकंड रीजन लिखो, मतलब देखो, सेकंड रीजन इज ड्यू टू हाइब्रिडाइजेशन. Due to hybridization. So this is like a revision of your 11th standard. If you remember do you remember what is hybridization?
Oh, yes, sir. Yes, sir. Yes, sir. So basically the orbitals will form four. Suppose you have, they'll form same number of hybrid orbitals where all the orbitals will have same shape and same energy, and there are three types: sp1, sp2, sp3.
क्या बात है, मन खुश. Good. Okay. So now, okay, just look at this. Tell me the hybridization of carbon, alpha carbon in 1 and 2. What is the hybridization of alpha carbon in 1? sp. इधर डाउट क्या है? Why is a doubt here? Hybridization नहीं बता पा रहे हो बे? If there is one pi bond, it is going to be sp2. If there are two pi bonds, sp. If there are no pi bonds, sp3. यहाँ पे एक pi bond है, देखो इस कार्बन के पास one pi bond, so it is sp2. Here, what is the hybridization of this carbon? sp3, no pi bonds, it is sp3. Okay. So let's talk about sp2 orbitals and sp3 hybrid orbitals. I don't want to discuss what are orbitals. Remember, एक पूरा महीना हम लोगों ने एटॉमिक स्ट्रक्चर पढ़ा था, याद है ना? सो हम एक मंथ पूरा
9 classes.
ओके. सो देखते हैं तुम लोगों को कितना याद है एंड कितना मेहनत मेरा जो है वो काम आया है. सो टेल मी द नेम ऑफ ऑल दी 4 क्वांटम नंबर्स.
Magnetic quantum number, azimuthal quantum number, spin quantum number, and magnetic and principal quantum number.
ठीक है. So there are 4, right? Principal, azimuthal, magnetic and spin. Principal का वैल्यूज क्या क्या हो सकता है?
1, 2, 3, 4
numbers. ठीक है. Okay. How do we represent the principal atomic number? Which letter do we use?
M.
Good. Azimuthal के लिए कौन सा लेटर यूज करते हैं?
M. L. Sorry.
इसका वैल्यू क्या क्या हो सकता है?
0, 1, 2, 3.
रेस्टोरेंट खोल के स्मार्ट हो गया और
-1 to 1.
It's 0 to n-1. ठीक है. फिर ये मैग्नेटिक का है m का वैल्यू -L2 + L. s का वैल्यू ठीक है. ओके, गुड.
That's a spin.
वाह, रियल लग रहा है इंटरनेट एक्सप्लोरर यूज कर रही है.
So, no, I'm not like Harsha.
बेटर की बैड. Okay, she is not interested to continue the conversation. Okay.
I didn't understand.
बस time गया. I am not interested now. Okay.
Okay.
Okay, now you tell me what is the percentage of percentage S character in sp2 hybrid orbital. कैसे निकालेंगे? Good.
Is it 1/3 into 100?
Correct. देखो sp2 में what is the how many total there are 2 p orbitals and 1 s orbital,
And one
right?
S and they form 3 hybrid orbitals.
कितना है एक? So 1 by 3 into 100 कितना है? 33.33%. यहाँ पर s character कितना है? 1 by 4 into 100, that is 25%. So where is the s character more? Technically you are correct. In sp it has 50%, but now we don't have that, right? Okay, so sp2. So sp2 has, write down, sp2 has more s character than sp3. Okay, sp2, or you can write down haloarenes has more s character than haloalkanes. Okay, more s character than sp3. Now, why is it important? Let's talk about that. Why is the s character important? What is the shape of s orbital? Circular. What is the shape of p orbital? Dumbbell. Yaad hai? If any one of you go to the gym, it can be, I mean, depending on the orientation, aisa bhi ho sakta hai, x, y, z. So it's a dumbbell shape. Okay. What is the shape of d orbital? Double dumbbell. Okay. Fine. Now you tell me, मान लो s orbital है, मान लो p orbital. Out of these two, where is the chance of electron spending more time near the nucleus high? It is actually s. ठीक है, इसीलिए the s character is more important. तो since sp2 का s character ज्यादा है, can I say that, मान लो ये कार्बन एटम, इसका s character ज्यादा है, तो can I say that the electrons are more near to the carbon atom, near to the nucleus of the carbon atom? Can I say that? Okay, so write down the point. In haloarenes, the electrons are closer to the carbon compared to the haloalkanes. Okay. Now you tell me, since the electron are near carbon, bond length कम होगा कि ज्यादा होगा? कम होगा ना? So therefore the bond length of haloarenes are lesser than haloalkanes. रियल लग रहा है, स्पेस में है. Okay, now you tell me which one is easier to break, a longer bond or a shorter one? Which is
Longer bond.
longer one. So therefore, again, haloarenes are difficult to break because they have a shorter bond length. Okay, that is the second reason. Third reason लिखो. थर्ड रीजन लिखो. अब न्यूक्लियोफिलिक रिएक्शन होने के कितने तरीके? What are the two mechanisms? There are two mechanisms. क्या? Elimination अलग है पूरा. SN1 and SN2. ठीक है? So now we have been discussing with respect to SN2. Did you observe that? We did not create a carbocation. We were talking the bond is breaking and it is coming and attacking from behind. Let's talk in terms of SN1. Okay. So in terms of SN1. In terms of SN1. Let's see why not SN1. Why can't this guy show SN1? So what is the first step in SN1? Formation of carbocation, this bond will go, so it will form positive charge here. This is the carbocation that you are getting. This is highly unstable. Can you tell me why? Is it aromatic? This is highly unstable. Remember, I told you, whenever in a double bond, there is a positive charge. याद है क्या? Double bond में positive charge जब भी directly लगा हुआ होता, that is not stable. Okay. So this guy is highly unstable. So that's why SN1 also out cannot happen because of the instability of phenyl cation. This is known as phenyl cation. Due to the instability of phenyl cation, the phenyl cation that has formed is highly unstable. And write down the last point, which is the last point of the lecture. See the last point, everyone, very easy. OH minus is a nucleophile, right? So nucleophile has electrons. So if it, now you see here, this benzene ring has also too much electrons, right? So they will face huge repulsions from each other, isn't it? Nucleophile already rich in electrons, and this benzene has 3 pi electrons. So they will repel each other. Due to this repulsion, they won't react. So these are the 4 reasons. Fourth reason is due to repulsion between the nucleophile and the pi electrons of the benzene ring. Due to the repulsion between the nucleophile, or you can say, you can write down the incoming nucleophile and the pi electrons of the benzene ring, there is a huge amount of repulsion, due to which no nucleophilic substitution takes place. Understood? Any doubt? Any doubts? Anyone? Okay, fine. Homework. Write down homework. Important. You'll get a huge amount of homework. Homework लिखो. 6.22 का second part. Fifth part. 6.20. 6.17. 6.16. 6.15. 6.14. Yes, that's it. Wait. In text, ये क्या चल रहा है? I rarely give you homework, or I give it in plenty. For example, 600 questions. Where is that? Where is that homework? I gave them 600 or 900, right? Questions, 300 questions. Where is that? Where is that? Baat gayi. In text question, write down 6.7, 6.8, 6.9. Okay. Adios, amigos.